Okay, welcome back to my video podcast and live stream on the future of business and technology. I'm Bernard Ma, and I'm excited to delve into how Altera's groundbreaking FPGA technology, a type of semiconductor that can be programmed and reprogrammed, is transforming the future of AI. Join me as we uncover real-world AI applications, innovative solutions, and insights from industry leaders that are shaping tomorrow's technology landscape. And to help me untangle this topic today, I'm super pleased that we have a great panel with me here today. We have Sandra Rivera, who's the CEO of Altera, which recently spun out of Intel. We've got Thomas Somers, who's the CEO of Positron AI. We have got Tom Catalino, who's the Vice President of Criticallink, as well as Dr. Rania Hussain, who's an Associate Teaching Professor at the University of Washington. Welcome, my panel members. So maybe we can start with you, Sandra. Do you want to give us a very brief overview of who you are and what you do?
Yes, sure. Thank you so much, Bernard. So I'm Sandra Rivera, and I'm the CEO of Altera, the only pure play, top to bottom, cloud to edge FPGA company in the world. And I'm very happy to be here with all of you today.
Fantastic. And Thomas, do you want to go next?
Yeah, I'm Thomas Summers, founder and CEO of Positron AI, where we're developing systems that leverage FPGAs to be able to accelerate machine learning models and have about a 5 to 10x performance per dollar advantage over competing platforms.
Fantastic. And Tom?
Yes, I'm Tom Catalino, one of the founders of Criticallink. We're a partner with Altera, and we provide off-the-shelf solutions that allow our customers to engage with FPGAs in the industrial marketplace.
Fantastic. And Dr. Hussain?
I am Rania Hussain, a faculty member of Electrical and Computer Engineering, and I am the founder and director of the Remote Hub Lab at the University of Washington, and we have been collaborating with Altera on several projects regarding FPGA technologies. Great to be here with you all.
Yeah, really good to have everyone with me. Before we go into the content, let's have a quick look at Altera's journey of innovation in this quick video.
From humble beginnings to global innovation leaders, we have been on a journey, boldly going where no company has gone before, to make groundbreaking discoveries in the world of programmable logic. It all started in 1983 in Silicon Valley, when a small team of semiconductor veterans, fueled by a desire to solve real-world problems, dared to rethink integrated circuit technology. In 1984, this team, then known as Altera, unveiled the world's first programmable logic device, capable of being programmed, erased, and reprogrammed, altering the course of digital design and of innovation. As the new millennium dawned, so did the next phase of Altera's innovation. Taking advantage of Intel's advanced manufacturing processes, Altera's chips grew to over 1 million logic elements. Today, Altera is leading the integration of artificial intelligence and programmable logic, which we call FPGAi. And this is just the beginning of more extraordinary discoveries, innovations, and endless possibilities.
We are Altera, accelerating innovators.
So that was super interesting. Lots of innovation happening there. So Sandra, can you talk about the state of the FPGA industry and Altera's position in it, and in particular the FPGAi solution you announced at Embedded World this year?
Yes, indeed. Let me just start by zooming out a little bit and just talk about how the continued exponential growth in data and the need to process and move and store and secure that data just continues unabated. And because of that, more high-performance computing platforms are required, with FPGAs playing a crucial role because of the power, performance, and area efficiency of FPGAs. And for over 40 years, Altera has had a leadership product portfolio that addresses broad applications from the cloud to the network and out to the edge and embedded market segments. The FPGA market overall is growing, with AI being TAM expansive, adding just a huge opportunity for all of us that are in this high-performance computing business. Altera right now is entering into this new era of FPGAi with both great silicon devices, software platforms, and design automation to help developers really innovate a lot more quickly, cost effectively, and efficiently to ramp their solutions out in the market. And you'll hear from some of the other guests of all the innovation that they're driving in their own market segments and companies. Most recently, Agilex 5 is the first and only FPGA product that has infused fabric, so an FPGA infused fabric across the portfolio, and we'll talk a little bit more about that later. We have an Agilex 7M series memory, high bandwidth memory product portfolio that is really well suited for transformer architectures, which of course we know is all the rage in AI solutions today. And we also, because we've incorporated the AI capability into our overall software platform, we have a way that we can actually add AI into a design flow, into an FPGA design and application in a push-button manner. And the way that we do this is by combining both the open ecosystem, OpenVINO software with our own FPGA AI suite, so that we can convert trained AI models into optimized IP that can then be easily deployed on Agilex devices. So it just makes adding AI as simple as adding any other IP to your FPGA solution. Most recently at Embedded World, as you mentioned, Bernard, we did announce Agilex 5 being broadly available with a free Quartus design environment. Quartus is our software design and tool flow. And we're just trying to lower the barriers of innovation, increase the market participation so that we can accelerate the rate of innovation. And by providing this free Quartus software environment, we are making it more possible for our developers to add intelligent, flexible AI silicon solutions to their applications. So overall, we just think that the future of FPGAs and what we call FPGAi, which is this combination of the silicon platform, the software capability, and the ease of deployment in terms of just more AI compute-intensive capability in your FPGA design flow, just makes it an exciting time for developers to include FPGAs as part of an overall AI solution.
Yeah, this is fascinating and exciting, and perhaps suggesting a new era in the history of programmable logic. To help us understand this trend at a practical level, I would like to bring in Thomas Somers from Positron AI to give us a customer point of view on this development. So, Thomas.
Yeah, thanks. So Positron has been developing with Altera Agile 7M for almost the past year, specifically for accelerating transformer-based models. So if you think about the past year and a half, the revolution in the AI space of large language models and applications like ChatGPT, fundamentally these have been powered by a neural network architecture called transformer that has become the dominant player, especially in the past year and a half. And fundamentally, it has very different requirements in terms of the compute to memory, both bandwidth and capacity ratio of previous neural network architectures like convolutional neural networks, LSTMs, RNNs, et cetera. And so fundamentally, what we saw with Altera's Agile 7M line was the fact that you had both this very high bandwidth HBM, high bandwidth memory, as the name implies, that enables all of the performance. So actually be able to generate tokens very quickly. If you think about the text actually going across the screen when you're using ChatGPT, having that be as fast as possible, but also being able to leverage extremely high memory capacity that the DDR5 attached to that FPGA enables us to be able to have significantly larger models, longer context links, all of the things that can enable next generation applications. And so we're utilizing these FPGAs, putting multiple of them together in a box, utilizing the high bandwidth SerDes connectivity going between those FPGAs to enable scaling out from the base level performance of just a single device, and then are able to interconnect that up to having many of these servers in a rack or across multiple racks to enable multi-trillion parameter models that we think are going to become the real standard going into the future. So really, it fundamentally comes down to FPGAs enable drastically different ratio of compute to memory bandwidth ratio than what GPUs and other platforms can enable, and the specific ability for us to reprogram that FPGA to take advantage of new advancements in neural network architectures rapidly, we think gives us a huge advantage in system building compared to what you're able to do with, be it GPUs, CPUs, or any other platform out there, and be able to get to market way faster and with way more flexibility than if we went out and designed a custom ASIC ourselves.
Yeah, that's absolutely fascinating. So now perhaps it would be good to hear from one of Altera's partners, Tom Catalino from Criticallink, about the state of the ecosystem surrounding the FPGAi trend and the ways Altera's partners are helping customers to get new AI-enabled applications to the market. So, Tom.
Yes, thank you, Bernard. And Criticallink has been a part of the Altera ecosystem for a bit over 10 years. And we've had a great relationship with Altera, bringing FPGA off-the-shelf hardware to market for our customers to leverage and get their products to market very quickly. It's a very exciting time to be a partner with Altera right now, with the FPGA AI suite, FPGAi, as well as the release of the Agile X5, which is a great platform for fielding FPGA based AI solutions. The FPGA is a very versatile tool to use in industrial and a wide variety of applications. And the reason why is because the FPGA is really well suited to data acquisition. As Sandra talked about, there are large volumes of data that are being acquired these days. And in many cases, it's being acquired by an FPGA. The FPGA is right out there at the edge, out in the front, collecting image data, collecting video data, collecting spectral data. So large volumes of data are being collected on a continuous basis. And this creates a large volume of data that needs to be processed somewhere, right? And what we're finding is with the FPGA, processing that data in the FPGA right there at the edge where it's being collected, provides a huge advantage for our customers. And a number of those customers are doing a variety of different things, right? So they might be doing defect detection on a manufacturing floor. So this allows them to collect the data as product is passing by and identify defects as product is being manufactured, and be able to take action right then and there. So that provides a huge advantage. Another advantage, again relating to the large volumes of data, is for the FPGA and the AI being implemented in the FPGA to perform significant volumes of data reduction. So there's a large cost to sending all of this data that's getting collected up to the cloud for processing and then pulling the data back. There's cost associated with transmitting that data. There's cost associated with processing, and then there's actually cost associated with pulling the resultant data back out of the cloud. And all of this can be reduced by applying AI at the edge with an FPGA. by having the FPGA AI process the data as it's being collected, identify the interesting portions of that data, then clipping that out of the data stream and then only sending that up to the cloud, customers can significantly reduce their cost of operation. And then finally, what we're seeing in the industrial space as well is FPGAs are very well suited for embedded applications. PCs, server class PCs with a GPU card inserted in the back, they're not nearly as robust as a hardware platform that was designed to operate in the industrial space. And so this is another place where FPGAs are really helping to build the quality and reliability of customer end solutions.
Fascinating. Thank you very much. Yeah, this is all a lot of innovation happening in this space that will really, I guess, accelerate this whole AI space. Let me now turn to our panelists from the academic community. Dr. Hussain, can you comment on how universities are preparing students for AI and what the main challenges are?
Sure. Thank you, Bernard, for the question. AI has indeed disrupted the educational industry, and educators are actively exploring ways to leverage its capabilities for enhancing the learning experience of students. So bridging the theory-practice gap is often a challenge, but through research and innovative pedagogy, students would gain exposure to real-world challenges and cutting-edge technologies like FPGAi, which ensure their readiness for the workplace. I would like to mention 2 use cases we are developing in the Remote Hub Lab at the University of Washington. One project aims to promote telehealth practices by enabling remote wound monitoring post-surgery. This involves capturing high-resolution medical images and processing them in 3D to extract precise measurements. So having FPGAi will enable real-time processing, which would be crucial for prompt and accurate monitoring. That's one example. The other one, we are working with Altera and Labsland on a project to create personalized learning systems powered by AI that can adapt to individual students' learning styles to enhance their understanding and retention of material. We believe that AI-driven data analytics in this case will help educators find areas where students struggle, which would allow for prompt and targeted interventions. It's definitely a great time to be partnering with Altera on the FPGAi platform for these upcoming projects we're working on.
Very good. Thank you so much. Let's come back to Sandra. I would love to know your views on where you think FPGA technology is going in the future and what are the new challenges, technologies, and applications that you see?
As you heard from our guests, there's just a lot going on in terms of all of the different types of applications that FPGAs are utilized in, whether it's in that cloud or data center, network, or edge and embedded applications, and particularly where we look at all types of computer vision, defect density, the ability to use AI for medical applications, for not only detection of tumors way before the human eye can see anything, but also in all the ways that we learn in community with federated AI and the way that you can localize data to train a model, but then contribute those learnings to a centralized data center so that you're not compromising someone's personal information, but you are contributing to an overall model. So this idea of federated AI learning is something that is being really utilized more broadly and more pervasively in medical types of applications. But beyond that, we just see the market for FPGAs growing, right? It's a $55 billion TAM over the next 5 years. We see a lot of growth accelerated by AI. We anticipate that in 2028, the market for FPGA AI solutions could be as much as $3 billion and growing. So an overall market TAM of $13 billion by 2028, with a lot of that growth in AI happening at the edge in these embedded applications. Over 75% of our customers say they plan to deploy FPGAs in their AI solutions over the next 3 to 5 years. So just lots of growth opportunity across many of the segments. And with our portfolio, we just started the high end with Agile X9, our top of the line product that has this leadership ADC and DAC capability used extensively for all types of defense and aerospace applications. We then waterfall down to Agile X7, which focuses applications in cloud, in the network, in other compute-intensive types of applications, including, of course, AI. And then, as I mentioned, Agile X5 is our leadership product, not only in terms of performance per watt, but also with this AI-infused fabric and with the software that makes it easy for developers to incorporate AI into their FPGA solutions and modernize, if you will, with, as you heard from Thomas and Tom, just more machine learning and AI capability into their existing platforms. And then coming soon, we have Agile X3, which is really designed for that leadership capability in the power and cost-constrained, broad base of embedded applications, whether that's retail, manufacturing, industrial, automotive, many different application opportunities there. So as we see the ongoing capabilities in process technology, so the shrinking of process technology with new nodes, more chiplets, more packaging innovations, more IP, an FPGA really can incorporate all of those new innovations into an existing solution where we're continuously, because of the reprogrammability of the platform, innovating forward and enabling customers and partners like Criticallink and Positron just to be able to just keep up with the latest technologies and to offer new innovations and new value creation opportunities to their markets. So just a lot going on across the spectrum. And I certainly want to just comment on some of the insights from Dr. Hussain, which is we've got to prepare the next generation of innovators and inventors for the future, and the programmability, the flexibility, this flexible intelligence that an FPGA provides, and particularly in this FPGAi world, is just a great testament to the ways that we're investing in our future talent and our future leaders in the tech industry.
Very good. Yeah, I completely agree. Thank you, Sandra. Let's go to Thomas now. What's your take on the future of the FPGAi?
Yeah, I think to comment a little bit specifically on our portion of the AI market we're targeting, which really has been exemplified by ChatGPT and similar applications. Right now, the key user experience are things like these chat interfaces, be it through as a personal assistant with ChatGPT, or if you're leveraging it for building out a support service for a website, be it text or audio if it's a call center, etc. And fundamentally, those applications are limited by the bandwidth of humans. So it only has to ingest at the rate that a human can actually type or provide information, and limited by the output necessary to be able to support human reading speed. But as we look into the future of where we see those applications going, I definitely think that it's going to be much more involved for machine-to-machine communication. So having a whole series of models that are doing different parts of analysis of massive amounts of data, and trying to glean both real insights from a lot of disparate data, but also then actually synthesize that together in a way that can be consumed in a much more compressed form by humans. But sort of all of the processing that needs to be done long before it gets into the form that a human would then consume still requires a lot of this token generation and capacity. And so systems today that are really only being built and can't even serve human reading speed of performance are just not equipped for being able to enable these future applications that myself and a lot of other people are actually trying to build. And so I think the fundamental advantages what we're trying to do with Positron is leverage the greatest technology available to be able to drastically, order of magnitude increase the performance, and we think most importantly for actually getting things deployed, the performance per dollar of these systems. And so we see, like I said earlier, that FPGAs fundamentally enable us to build something very quickly, be able to rapidly iterate on different design functions, and get us to that long-term performance vision and goal. I think that the key application, or the enablements that we're driving for that is can we get this massive performance win? Can we have from both a capex and opex? So the full energy efficiency of an FPGA as well, enabling much lower long-term operating costs of system. Like if you can get this order of magnitude improvement from today's systems, that drastically decreases the both need for these massive data center investments that you hear all the major companies talking about. Do I think that they're actually going to reduce their spend? No, they're actually going to increase the total amount of capacity that they deploy. So we just see this as such a huge unmet need right now that thankfully we're able to take advantage of utilizing FPGAs.
Wow, that's great. Thank you very much. Tom, how is your company moving to better support customers building AI applications with FPGAs?
Yeah, Bernard. What Criticallink is doing is working with the Agile X5. Sandra mentioned that the Agile X5 is a great platform for AI, and we certainly see that with the tensor blocks, the upgraded tensor blocks that are in the Agile X5. It's a fantastic platform for bringing AI to the field in an FPGA. And what Criticallink is doing is providing off-the-shelf hardware solutions that allow customers to get to market very quickly. Time to market has always been a key, and it just continues to be extremely important for our customer base and for many OEMs. So what Criticallink has done is developed a single board computer based around the Agile X5. And that single board computer provides an array of high-speed interfaces in an off-the-shelf piece of hardware that customers can immediately leverage to bring to market for their embedded applications. And then we're also going to be bringing to market a system on a module based around Agile X5. So rather than a single board computer in about a 6 by 9 inch form factor, this system on module is about 3/4 of the size of a business card. So a really compact form factor that allow customers to customize the hardware into their application much more seamlessly. And then what Criticallink will be doing from there is leveraging the Altera FPGA AI suite, pre-integrating it onto both of these hardware platforms, so that customers can then take this off-the-shelf hardware and as Sandra mentioned, with very ease of use with the Quartus tools, bring their models into the hardware and get to a solution where they're able to have customized hardware and their customized AI running in their industrial applications quickly and efficiently. And further, this hardware is developed for the purpose of being in production and standing the test of time. We see a number of companies out there sometimes trying to leverage development systems or maker type systems that are really not intended to be fielded in the industrial space, and then faltering or failing sometime, in the future, whether that's because the maker system has evolved unexpectedly, or if because the product is falters under the tough environmental constraints of the industrial market. So our products are designed to operate in this space. They're designed to stand the test of time, and they're designed to help customers get a robust solution out to the field, incorporate AI, and have much success into the future.
Very good. Thank you so much. Dr. Hussain, what do you think universities need to do better to prepare our graduates for this new world of AI?
Certainly, Bernard. Echoing what Sandra and my fellow panelists mentioned and shared, in my opinion, I believe that to better prepare graduates for the new world of AI, universities need to focus on several key areas. One crucial area for sure is strengthening partnerships with industry leaders. These collaborations will ensure that students have access to the latest technologies and real-world insights, which are essential for the professional growth. That's one area. Another area is increasing opportunities for practical learning, which could be achieved through interdisciplinary projects and internships that allow students to apply theoretical knowledge in practical settings. Additionally, encouraging students to engage in innovative research projects will help them develop critical thinking and problem-solving skills, which, in my opinion, are invaluable in the rapidly evolving AI landscape. Also, I believe that universities should ensure that their curricula are flexible and adaptive to keep pace with the rapid advancements in AI and FPGA technologies. Continuous professional development of our faculty is equally important too, to ensure educators stay updated with the latest tools and methodologies. I would like to take this opportunity to invite my fellow educators everywhere to collaborate to shape the future of education and preparing students for the new demanding workplace.
Very good. Thank you so much. Yeah, I very much agree with you. I think education will be disrupted in two different ways, because the way we teach will be interrupted by AI, but also what we teach needs to drastically change. So thank you very much to all my panelists today. Thank you, Sandra. Thank you, Dr. Hussain. Thank you, Tom and Thomas, for this fascinating conversation about some of the hardware that can really redefine the future of AI. If you ever want to rewatch this or many other conversations about the future of business and technology, simply head to my YouTube channel or connect with me on LinkedIn, or indeed connect with any of the other panelists or Altera on LinkedIn. Thank you very much, and I will see you soon. Thank you.